Welcome back to lesson 2, right? So in this lesson, you're going to be introduced to the principles of computer programming. In the last lesson, we said computer is an electronic device that accepts input, right, as data, processes this input, and then generates a result called information. So that means the computer on its own, the computer device on its own is not really a useful entity, right? Because it needs the human, he needs a programming force driving its operation. It needs humans to tell it what to do before it can work or execute data, right? So a complete functional computer comprises of two parts, right? The hardware, we have the hardware and the software. The hardware are the physical parts, that parts of the computer that we can see and touch. Like the monitor, you can touch the monitor, we can touch the CPU, we can work with the keyboard, the mouse, joystick, and all that. So those physical parts we can see and touch are the hardware parts of the computer. While the software are those programs that we cannot touch. We can't touch them with our hands, right? Because they are software, they're just what we use to communicate with the computer. So the software stands as the middleman between, it's an interface between humans and the computer hardware. So for us to communicate with the computer, we need to communicate through the software. And what are the software? Software are suites of programs working together to provide a solution to make life easier for us as humans, right? That's the simply put it that way. But when we go deeper to look at what a program is, what is a program? A program is a step-by-step instruction or processes written down for the computer to follow to solve a particular problem. So a program just tells the computer what to do and how to do it in order to solve this kind of problem. That's just what a program is. So by programming, we are now instructing the computer on how to solve a particular problem. So there are two types of programming. We have the system programming and the application programming. I can just say two types of program, the system program and application program. So the system programming is done by the computer manufacturers. It comes with the computer. So those programs that are inbuilt when the computer is manufactured. So those programs now help other programs that like the application programs to to function. So the system programs are those programs that comes with the computer. When you buy a new computer now, that they are those basic programs that comes with it. But the application programs now are programs that written by a programmer to solve a particular problem, right? So example of a system program is the operating system. So we have like the Windows, we have the Mac OS, the Mac operating system, the Linux operating system. Those suites of programs that comes with the computer that is written by the manufacturers to help the computer perform or work smoothly, right? Those are the system programs. While the application programs are now written by programmers to solve a particular problem. We have example like your Microsoft Word now, your Excel, your for graphic designers, we have the Corel Draw, and all those kind of programs or softwares that you install on your computer after buying them. So when you go to buy like your laptop or whatever, you go out to buy after buying your system, you now decide to install different programs. Oh, I like this kind of software. I like this one. I want to use this. I work with this one. So those extra ones you install are now the application programs because they are solving a particular problem for you. So those are the two types of programs we have. We have the system programs and the application programs. And the one we are going to be focusing on is writing the application programs because we are going to be teaching the computer, telling the computer, writing instructions for the computer to perform a particular task. So without further ado, let's get right into it.
So, introduction to programming. Let's get into the business of today. Um, so what is programming? Programming is a process of instructing a computer to perform tasks by providing it with a sequence of coded instructions. So, like I mentioned earlier, programming is just writing instructions for the computer in a language that you know, right? So you just communicate with the computer, telling the computer how you want it to perform a particular task. That's just simple as that. So let's say, for example, you're working for a company, and this your company have an issue, okay? Um, so we want to, and they come to you and say, we want to be able to get our users' information or clients' information, right? So we need you to build a website or an app to help us achieve this. So what you do is you just write this instruction, telling the computer, this is what I want you to do. Get me when a user visits this page, ask the user to input the name, and then when they give you their names and information, you send it to the company. So that's just as simple as that. So the importance of computer. So a computer forms the backbone of modern technology, enabling the creation of softwares, websites, apps, and much more. So without programming, it's it would be difficult for us to communicate with the computer. So programming just helps us tell the computer this is what to do and how to do it. That's it. So why do we learn programming? Why learn programming? For career opportunities. Yeah, because everything is going digital now, and we are in the information age. So becoming a programmer gives you an edge, right? When it comes to opportunities, market in the market that out there, because all the industries are incorporating technology to it. So whether you're banking sector, school, even agriculture, everyone is incorporating it, and sales. So everything is going online right now. So companies need programmers. So you're going to get like that. There's a need, a large, wide need for programmers right now. And problem solving skills. So becoming a programmer means you have the skill, this problem solving skill. You can bring about solution to a problem. So, and that's what creativity and innovation means. You can just say and come up with an idea of, okay, if a company can walk up to you and tell you, okay, this is what we're facing. How do you think we can solve this problem? How can we address this? But because you're a programmer, you already know how the computer works and how you can communicate with the computer to deal with that particular problem. You can just come up with an idea. Oh, okay, I think I've seen something like this before. I've done something like this. Or maybe you can just do it like this. You come up with, it makes your mind very creative, innovative. So, overview of programming languages. Like I said, programming languages are formal languages used to communicate instructions to the computer. Computer has its own language, right? So, in order to communicate with the computer, you need to speak the language that computer will understand, and that's what brings about programming language. So, types of programming languages. So, we have two types of programming language, and each has its own syntax and purpose, right? So we have the low-level programming language and high-level programming languages. The low-level programming language is called low-level because computer does not need to translate it. I'm just going to give you the overview of what I mean in low-level and high-level language. So the machine language is the native language of the computer and consists of zeros and ones representing resistors, representing on and off, yes and no, true or false, right? These are what these things represent. And computer use these zeros and ones to represent each alphabet. Now, that's like the native language of the computer, right? So we have close to the machine language, we have the assembly language. The assembly language is close to machine language because it uses mnemonics, signs, and symbols to represent each character, each words. And computer is closer to the machine language, but then it still needs an assembler. An assembler is the translator. It compiles the assembly language so that the computer would understand it. While the high level languages are language that reads like English, right? They read like English, you can read them out, and that's the one that we are written recently. Recently, that's what we've been using the high level languages. We're not writing the computer language. And in order for us to write high level languages, there's an introduction of a compiler or an interpreter. So an interpreter is the middleman that translates what you've written to machine language. It translates the high level language to low level language, that is the object code, so that the computer would understand it before the computer can even start processing. I will explain this better in the next class. So we have the integrated development environment. These are tools you use in programming coding. So what do you mean by I'm a programmer? What do you mean? There are tools and there are you know protocols. There are guidelines you need to follow, tools you need to use to become a programmer. And one of it is the IDE, the Integrated Development Environment. This is a software application that provides comprehensive facilities of programming for programming, debugging, and deploying code. So when you start writing code, you're going to be introduced to different kinds of IDEs. Right now, you can just go straight and download the Visual Studio Code. Let's start with that. Or first, for beginners, you can just download Sublime. Sublime is an integrated development environment. Go to App Store if you're using Mac, or if you're using Windows, whichever one you're using, just go go to your App Store and download the Sublime or Visual Studio Code. That's so that you can see the environment. But I'm going to show you what I mean in a bit. We also have the text editors. So for iPhone users or Mac users, it comes. I think it comes with all laptops or all devices, right? Whether you're using Windows or you would have a text editor. Yeah, it's lightweight tool for writing code. Or and most people prefer it because it's simple and very flexible. You can just to write anything, just your text, you just drop in your codes there. Or for advanced people would like to use the IDE because it has everything inside. It helps in debugging. It helps when you're writing, it makes it easier because of shortcuts you can use. But text editor is just simple, very simple. Just you can just write your code. So the next thing is okay. Let me show you an example before we move on. Let me show you an example of an IDE. Or let me just show you what I have here on my laptop. Um, so my this is Visual Studio Code, and this is where you can write your codes. It's just an IDE with an IDE that helps just where programmers write codes. So you can just write your code, and this highlighted areas are just recognizing the syntax of the language that you are writing. So I just wanted to show you what an IDE looks like. There's an zoom and something to begin with. Okay, for text editors, I believe your laptop will have a text editor. Just search for text edit. Okay. So the text editor is just a simple easy to use environment where you can just write your code. So to write code is very simple for the beginners. So if you don't have any IDE, you can download the Visual Studio Code or Sublime Text right now. You can just make use of your text editor. Right. I think Windows uses Notepad. Notepad, yes, Notepad for Windows. So let's go over to the virtual control system. So we have the version control system. The version control system are tools that programmers use to collaborate. It enables collaboration, code management, and tracking changes in project. So let's say it's a big project you're working on. You understand that programmers all over the world can come together to work on a particular project. How are they able to work on that particular project? It's because of the version control systems like GitHub. Right? I'm not really talk about GitHub as an example of a version control system. So it helps programmers from all over the world to work on a particular project. It helps in collaboration, code management. So if there's an error, you can always revert to your previous changes. You can just delete the error and update your code. You can pull someone's code, some of the code that was written outside of your country, you can pull it and make changes to that code and still push it back. So it helps programmers to collaborate wherever they are. It helps in tracking changes and also in managing code. So what have we learned so far? What have we learned so far? If you have any question, please don't hesitate to ask the question. Drop it in our Telegram channel or WhatsApp community. Just drop it there. Just reach out and ask your questions. So what have we learned so far? We learned about programming. We learned about programming languages and tools. The tools we use in programming. So by programming, you just need a laptop, an IDE where you can write your code to it. Just those softwares, the IDE, and the control system. That's if you are working on a team. Even if you're not working on a team, still upload your project so that or if there's any problem with the system or your device, or maybe you encounter a code and you don't know how to change it, can you back to your previous version of the code and you pull it back and continue writing it. So it's a good practice to to start using it right now, get used to it before you start working with a large team. So thank you very much for joining the session today. This is lesson 2. So we are going to be I'm going to be seeing you in the next lesson, which is lesson 3. And there we can talk about how computer executes code, how computer runs this program so that you can really understand what's happening behind the scene. Thank you. See you in the next one.